Okay, so that brings us to the next state variable, that is the pressure of gas. So let us try and understand what exactly constitutes the pressure of gas, or rather why a gas in a container exerts pressure. So pressure, as we all know from our previous knowledge, from our basic experiences, that pressure is defined as the force per unit area, right? So obviously there has to be some force and there has to be some area on which that force is acting for us to define, or rather let's say discuss about pressure, right? So, and we also encounter the pressure of gas quite frequently in our everyday lives. I'm quite sure all of you must have filled your automobile tires up to a certain value of pressure. So let's say if we have a container in which there is some gas, then in the first place, why this gas is exerting pressure? Where does this pressure come from? What is the force? Where is that force being applied? Now, as we have discussed previously, that these particles of the gas are in a state of a constant random motion. And due to this motion, they are colliding with themselves, and at the same time, they are also colliding with these walls of the container. And naturally, due to these collisions, due to this bombardment of particles, they are exerting some force on these walls. And this force per unit area constitutes the pressure of gas. So, the pressure of gas, if we say that, if I just write one point about it, the pressure of gas is due to the collision of its particles with walls of container. The particles of the gas are colliding with the walls of container, and as a result of this, they are applying or exerting some pressure. Now, if I ask you one very fundamental question related to physics over here is, suppose this container is kept on a smooth, frictionless floor, right? And the particles of the gas are moving, and we just discussed that they are colliding and exerting some force. Then my question to all of you is that why is this container not moving in the forward direction? Now, all of you might say that, so the forces which are being exerted are very small, or the mass of the particles is very less. But for your convenience, I had said that this floor is absolutely smooth. There is zero friction. So ideally, if there would be even a small amount of force acting on this block must move in the forward direction. But from our everyday experience, we know that is not true. That is not going to happen. Because if that were the case, if just filling a container with gas would start moving the container in one direction, then we simply need to inflate our cycle tires with some amount of air, and then the cycle would automatically start moving. We need not pedal it in that case, right? So the reason behind this is that as to why this container is not moving is the particles of the gas, my dear, are not colliding just with this wall. There are equal bombardments and collisions on this wall. There are equal bombardment and collisions on this wall and also on this wall. So basically, what I am stressing out over here is that the pressure of gas comes out to be same in all directions. Pressure of gas comes out to be same in all directions. So the next point which we need to understand about the pressure of gas is that we do not consider the effect of gravity on the motion of gas particles, right? So I'll just write it down over here for your reference. The effect of gravity is negligible on the motion of gas particles. Now, what exactly does this mean? What do we mean when we say that we do not consider the effect of gravity on gas particles, right? Let us try and have a very clear understanding of this statement. Suppose I have a container which is, let's say, approximately 1 meter in height. So let us take some height of the container as 1 meter. And within this container, I have gas particles, right? So obviously, a particle of gas which is at the bottom, as it moves up to the top of the container in its upward journey, the speed of the particle is going to decrease. You know that from your everyday life experience, that any object which is thrown up against gravity, as it moves up, the speed of that particle decreases because of the gravity, acceleration due to gravity, right? Similarly, if any particle which is at the top of the container and it now starts moving towards the bottom, the speed of this particular particle is going to increase as it reaches the bottom of the container. So as a general observation, what we can say is that at the bottom wall, the particles will be striking at a higher speed, and at the top wall, the particles will be striking at a lower speed, because any particle during its motion, upward motion, will experience a decrease in speed. Similarly, any particle during its downward motion will experience an increase in speed, right? So if this be so, if this be the case that the particles at the bottom wall are striking with a larger velocity, this would mean that they are exerting more force, and a more force would lead to a more pressure, or rather let's say a higher pressure at the bottom wall and a smaller value of pressure at the top surface or the top wall. However, just in the previous video, we had said that the pressure of the gas is same throughout. It is same in all the directions. That is, we always report one single value of pressure in this entire container. Now, why do we do so? Why are we saying that the pressure is same when we can notice that the particles are striking at a greater velocity at the bottom surface? You all might say that the effect of gravity is negligible on gas particles. But my question to you is that why is it negligible? What crime has gravity committed in this particular case that you are simply ignoring one of the most fundamental and basic laws of nature, that is gravity? So to deeper understand, to have a better understanding of this particular point as to why the effect of gravity is neglected. Of course, you know by now that the effect of gravity is negligible when you are giving a single value of pressure. But the question over here is why? Why is this effect of gravity negligible? So to understand this particular why, we will carry out some very simple elementary questions. So suppose this container, which I had already said has a height of 1 meter, and let's say the gas particles, the speed of the gas particles, I'm just sharing some numerical data with you. The speed of the gas particles is in the range of 10 raised to the power 6 meters per second. This is the approximate speed with which the gas particles move. So if we carry out some rough calculation, like let's say what is the time needed by this particle to reach from the bottom to the top. So we all know, if we assume constant speed of the particle, so we all know that time is equals to the distance by speed, and the distance it has to cover is 1 meter, and its speed is 10 raised to the power 6 meters per second. This is the approximate speed with which the gas particles move. This would give me the value as 10 raised to the power minus 6 seconds. So in this short duration of time, the gas particle completes its journey. Now there is this very simple equation of motion, which I am quite sure you all must have studied in your physics classes in your earlier standards, that for an upward motion, the value of V is equals to U minus GT, right? So if I just substitute the values over here, that is, the initial velocity of the particle was 10 raised to the power 6, and approximate value of G is around 10, and the time it takes to complete its motion is 10 raised to the power minus 6. So this gives me 10 raised to the power 6 minus 10 raised to the power minus 5, right? So I hope you are smart enough to understand that this number over here is very small as compared to 10 raised to the power 6. This is 10 raised to the power 6 is 1 followed by 6 zeros, right? So that is almost 10 lakhs. And this is 10 raised to the power minus 5, which is 0.0000, 4 times 0 and then 1. So obviously this quantity over here is very small as compared to this quantity. And this can approximately be written as 10 raised to the power 6 meters per second. So what does this simple calculation out here convey us? It conveys this very deep meaning that the particles of the gas are striking at the top wall with approximately the same speed as the speed at the bottom. So that is why we are ignoring the effect of gravity, because in everyday life, the containers which we use have a very small height in comparison to the speed of gas particles. Now what happens as a result of this is that due to this very small height, the gas particles take a negligible amount of time in completing their to and fro motion, that is from the bottom to the top or from the top to the bottom. Now due to this, what happens is that during this negligible amount of time, you are not giving gravity sufficient time to cause any significant amount of change in the speed. So we are basically saying that the particles strike the top wall and the bottom wall with approximately the same velocity, and that is why we are ignoring or neglecting the effect of gravity. Now suppose if I paint a hypothetical situation, if I try to imagine some unrealistic hypothetical situation that we have a container whose height is, let's say, approximately 10,000 kilometers, right? So obviously you don't find such a tall container in your everyday life. So if we have such a high container, then in such a container, you cannot neglect the effect of gravity. You cannot neglect the effect of gravity. Effect of gravity. Why is that so? This is so because if the container is so tall, then obviously the gas particles would require some time in traveling from the bottom to the top, and in this time frame there will be some change in its velocity, and as a matter of fact the particle will be striking at a lesser speed on the top wall. So we'll have to say that the pressure at the top wall is less and the pressure at the bottom surface is more.